Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to graph a couple of polynomial functions that are in factored form. The first one, f of x equals x plus 1 quantity cubed times x minus 2 quantity squared. Let's begin with the end behavior. So the end behavior, this is like x to the fifth power because I've got an x cubed times x squared. And we know that the end behavior will be like that. So up to the right, down to the left. For zeros, we have -1 and +2 from those two factors. That's like x minus -1 and x minus 2. Or you can also think about what makes x plus 1 equal to 0 and x minus 2 equal to 0. The zero behavior, because, let's start with the 2. Because that exponent is a 2, that means that it's going to turn. It's either going to be like this or like that. At -1, because its multiplicity is 3, and let me write that down. Because its multiplicity is 3, that means that it will go through that 0, but it's also going to change from concave up to down or down to up. So it'll either look like this or it will look like this. We can anchor some points on this graph. We already know the two zeros, so we know the two x-intercepts. For the y-intercept, that is where that's equal to f of 0. So we substitute 0 in, and we get 0 plus 1 to the third power times 0 minus 2 squared, which is 1 cubed times -2 squared, which is 1 times 4, or 4. So I've got a few points. I know how it behaves at the end. I know how it will behave at the roots. Let's go ahead and give this one a shot. I know my zeros were -1 and +2. Scale's a little shaky here, huh? Use graph paper. The y-intercept is at 4. I know at the 0, at +2, it's supposed to turn around, and it's coming from the y-intercept, which is already above. So we know that this one has to do something like this. And the end behavior to the right of that 0, we know it's going to be going up to the right. So that one's good. And we also know to the left of -1, that's going to be coming down like this. Now, the only thing that remains to be done is make the connection. And what I've got here actually is probably not valid. Let me make a quick adjustment. I know that the turning point should be in the middle of -1 and +2, so probably looking at something like this instead. What I had was pretty good, but that 4 isn't a maximum point. It's going to continue to go up. Anyway, that's a quick sketch of the graph. I put in the two zeros. I put on the y-intercept. I talked about the end behavior on both ends, and then I talked about the behavior near the zeros. And so those are the things that will give you a quick sketch. The one thing that we're not accurate enough with yet is what's happening up here. Where does that exactly turn around? And we'll actually learn to do that when we get to calculus. All right, let's go ahead and try one more. We use the same approach. Graph the polynomial function f of x equals -x times x plus 4 times x minus 1 quantity squared. So let's start with the end behavior really quickly before the pencil goes bad. The end behavior, this behaves like -x to the fourth power. because we have x times x squared, and there's a negative out in front of that. So we know that it's going to look kind of like a parabola opening downward. X to the fourth is like x squared, just everything's going to be much steeper in the decline. Right. The zeros. X equals 0, x equals -4, and x equals +1. The first two zeros that I wrote down have multiplicity 1, so these will both be passed through. At 1, there is multiplicity 2, so that means it's going to turn around. We've got the three zeros. We should get the y-intercept. And again, that's f of 0. So f of 0 equals -0 times 0 plus 4, not squared, times 0 minus 1 squared. That's going to end up equaling 0. When 0 is one of your roots, when 0 is one of your zeros, then the y-intercept is also going to be at the origin. This would have been -0 times 4 times -1 squared, but because we're multiplying by 0, that just equals 0. So let's put the points on the graph that we know about. We've got a 0 at 0, another one at 1, and another one at -4. We know for the two roots that are furthest out, the one furthest to the left, the one furthest to the right, we know that the end behavior tells us that it's going down from there. So this one's going to go like this, and this. At x equals 1, it's supposed to turn around at that. So it's not going to go up and through 1. It means it's going to turn around at that point and still has to come back up to the next root. Now 0 is a pass-through, just like -4 was, so the rest of the graph is going to look something like this. We could have used a sign chart. For instance, we could have plugged in, say, -2 and saw what kind of result we got, which would have told us the graph above at that point. So for example, f of -2, that would be the opposite of -2 times -2 plus 4 times -2 minus 1 squared, which would have been +2 times +2 times -3 squared. 2 times 2 times 9 is what I see. So this would have been 36. So it actually would have gone much higher than what I've shown. But again, this is just a quick sketch of the behavior of the graph. When we want to get more precise, we would have tried to find the turning point. And that's, again, something that we'll see in calculus. All right, so a couple of quick examples of graphing a polynomial function that's in factored form.